Why do we see the night sky as dark? It seems like a silly question, but it has puzzled astronomers for hundreds of years, and it holds the ultimate secret to the universe. As early as 1826, Olbers asked why the night sky is black while looking up at the sky. The first time you hear this question, you might think the scientist is crazy. The night sky is not black, should it be as bright as the day? This is also worth discussing. We can take it for granted. But astronomers don't jump to conclusions based on experience, because there are numbers of stars that shine just like our Sunday. No matter how far apart they are, their light should reach Earth and theoretically fill the entire universe. Therefore, the sky we see should be eternally bright. So why is the night sky dark now? The first thing we think about is that those stars are way too far away. Even the nearest star, Alpha Centauri, is 4.3 light-years away, so its light reaches us in a minuscule way. So it's normal that we can't see, but it's actually wrong. If we split the universe into uniform spherical layers, centered on the Earth, and if each layer contained a certain number of stars, because of the homogeneity of the universe, a sphere twice as far away from the Earth would contain 4 times more stars. But according to the inverse square law, the total brightness of each layer is the same when viewed from Earth. That's because as light travels, the volume of the universe and the number of stars increases with the power of distance. The simple way to understand it is that the dimming light will eventually be cancelled out. Beyond that, one could argue that the stars in the universe might be unevenly distributed, which sounds plausible. But as scientists looked into the universe, that hypothesis was dismissed. Of course, there are those who would argue that there is so much interstellar dust in the universe that it blocks the light of distant galaxies from reaching us. Because according to the law of conservation of energy, light from distant galaxies heats up the dust material, and the dust starts to re-radiate the absorbed light and shine like starlight, lighting up the entire night sky. So why are our nights still dark? This cannot fail to mention the famous Olbers Paradox. We can explain it in 2 ways. 1. If the universe has been around forever, so there must be a finite number of stars. This means that the universe is finite in space scale, and it must also have a boundary. 2nd, if the number of stars were infinite, the universe could not have lasted forever, or the starlight would have had enough time to reach the Earth, and the universe must have had a beginning. In other words, the universe is finite in time, and that's one of the key pieces of evidence about the origin of the Big Bang. According to modern astronomical data, our universe began with a Big Bang 13.8 billion years ago. The first stars were born 400 million years after the Big Bang, and all kinds of stars and galaxies evolved. In other words, that's when the first light from stars appeared and traveled through the universe, but light takes time to travel, and those distant lights haven't reached us yet. Not only that, but the light we see from distant stars is actually stretched across the spectrum. That's because the universe is expanding so fast that the light from those distant galaxies is become infrared light. In simple terms, our universe isn't actually dark, it's just that the human eye can't see the light. And the dark universe problem is pushing the observable universe into a very pessimistic future. Although the scale of our observable universe is 93 billion light-years, almost all distant galaxies are moving away from Earth at faster than light speeds. Their light never reaches the Earth. Imagine if there was another Earth in one of those galaxies, with intelligent life just like ours, and they were looking for aliens, but we could never contact each other. Because the universe is expanding even faster than the speed of light, we will never see each other.